All right, welcome back to Calc 2. So we are in the middle of doing some homework problems, and we're just going to continue on that vein. So number 7, okay, we're going to do, well, you'll see it in that description. I think it's 7, 12, and 13 or something. So an online retailer has determined that the average time for a credit card transaction to be electronically approved is 1.6 seconds. Round all of your answers to 3 decimal places. Use an exponential density function to find the probability that a customer waits less than 1 second for approval. Find that he waits for more than 3 seconds. And what is the minimal approval time for the slowest 5% of all transactions? All right. Pardon me. I would never pose a question to you in this particular way because when you take statistics, when you take probability, you have to memorize what this is. All right. You guys, I don't think you're, this is not the kind of class for you to be doing that. All right. There's already enough to remember. We're not doing this. So if I was going to ask you, I would give you the function. Okay. I would say, well, f of x is equal to 1 over 1.6 e to the negative t over 1.6. Okay. dt for t greater than or equal to 0. What I do expect you to memorize or to know is like the probability it takes less than 1 second. How do you set that up? Okay, and that's simply going to be the integral, right, from 0 to 1 of 1 over 1.6 e to the negative t over 1.6 dt. What is 1 over 1.6, right? Isn't that 5/8, something like that? Yeah. So I'm going to go ahead and change this to a fraction just because I find it a little bit easier to work that way. But so we have 5/8 integral 0 to 1, right? We've taken care of that. E to the negative 5t over 8 dt. All right. And at this point, we could do some use substitutions and work through all of this. All right. So we could say let u equal negative 5/8t. U equals negative 5/8. Okay, so we'll use this, right, as our du. At this point, we could also, right, we could say, well, when t equals 0, u, right, also equals 0. And when t equals 1, then u is equal to negative 5/8, right? So we actually could do negative integral, that's this negative, 0 to negative 5/8, all right? That's what this is. E to the u, du, because we have our du here, all right? So let's just go ahead and do that. That's going to be e to the u, right? From 0, negative, right? 0 to negative 5/8. Let's go ahead and change my limits. So we have e to the u from 5/8 to 0. Right? That's what this negative does. It swaps the limits for us. So this is e to the 0 minus e to the negative 5/8. Okay, so it's 1 minus e to the negative 5/8, and numerically, right, that's an 8. Okay, numerically, that is 1, where are you here? 1 minus second function e, right, to the negative 5/8. All right, great. 0.464, what did they say, 3 decimal places? 3. So that's going to be 0.465. Okay, so the probability that they're waiting for less than 1 second is almost half of them, right? 0.46, almost 0.50. So almost half of them wait less than 1 second for approval. Okay. Next question. What is the probability that they wait for more than 3 seconds? Okay. So that's going to be integral 3 to infinity. Okay. And this was 5/8 e to the negative 5/8t dt. And I would recommend, like, you want to do the same thing? I think we want to do the same thing. All right, so I'm going to put a negative here, negative here. We're going to say let u is equal to negative 5/8 t. Du is equal to negative 5/8 dt. So here's my du. Okay, so we have negative integral. We'll deal with that in a minute. E to the u du. Now, when t is equal to 3, u is equal to negative 15/8. And when we take the limit, as a goes off to infinity, or t goes off to infinity, right? U is equal to negative 5/8, and then we're allowing t to grow very large. So u is equal to negative 5/8 with a very large number, right? U is equal to negative infinity. Okay, so we have negative 15/8 here, and u is equal to negative, up here we have negative infinity. All right, so I'm going to go ahead and switch my limits. Okay, so what we're going to do here is yeah, we're okay. So we have negative infinity, negative 15/8. We have e to the u du. For a moment, I was worried because t has to be greater than 0, but u is going to be right. U is going to be less than 0. Okay, so this limit makes sense. So this is limit, right? As a goes to negative infinity, integral of a to negative 15/8 of e to the u du. All right. By the way, you could find you could find the general integral for this thing and just replace it, and then go back to t space, and then that's fine. Okay, there's several ways to do this, and they're all going to be okay. All right, so this is going to be e to the u, right? A negative 15/8 limit, right? As a goes to negative infinity. So this is e to the negative 15/8 minus e to the a, and this is limit as a goes to negative infinity, e to the negative infinity, all the way down there, does 0. So this is just going to be e to the negative 15/8, and we're set. Okay, minus 0, but that's it. Calculator, we have second function e to the negative 15/8. Okay. So 0.156, right? So people that are waiting longer than 3 seconds, about 16%. Okay, 0.16. All right. Which means 84%, right, or less. What is the minimum approval time for the slowest 5% of transactions? All right. So we have exponential function, right? Our exponential distribution looks something like that. So what we're looking for is, this is the probability is the area under the curve. So the 5% slowest transactions is going to be this 0.05 sitting over here. All right. And we need to know, like, what the heck value is that, right? So that all of this is only going to be 5%. Now there's two ways to do this. Okay. We can go from 0 to L. And if this is 5% and the whole thing's got to integrate out to 1, what does, what's the purple have to add up to? That's going to be 0.95. Okay. So it is entirely up to you about how you want to set this problem up. You want to go from 0 to L to say 0.95. If you want to go to L to infinity, which means we have to do another improper integral to get to 0.05. Okay, because all we're looking for is, like, what is this value? And it doesn't really matter how you want to think about it. Okay, that's just going to be how you're going to set your integral up. I'm going to say, you know what? I'll bet you've probably had enough of improper integrals for a little bit. Why don't we do it this way and figure out the L from that? Okay, so what do we have? We have 5/8 e to the negative 5/8 t, right? And we are going to go from 0 to L, and that's going to equal what? 0.95. I hope that makes sense. I can't ask you, like, are you following me with this? So I won't even do a back to U substitution. Okay, we'll do the U substitution, but I'm not going to keep it in U space. I'll go back to T space. Okay, U is equal to negative 5/8 T. Du is equal to negative 5/8 dt. Right? So here's my negative, here's my negative. Right? We have 0 to L. This is going to be in U space. So technically, we're just making a note. These are in U's. And we've got e to the u, negative, du. Okay, integrate. So we have e to the u, negative, all right, from u sub 0 to u sub L. And let's go back to our T space here, okay? I will do this, though. I will deal with my negative sign and let this be e to the u. And then we have u sub 0 and u sub L. Okay, let's go back to T space. So this is equal to e to the negative 5/8 t. And then I didn't know what L was, right? That was one of the unknowns. This was 0, right? This was 0 because we wanted to get this part. And we had to set this equal to 0.95. All right. So plug me in, right? We have e to the 0 minus e to the L is equal to 0.95. Well, I know what e to the 0 is, right? Oh, this isn't L, this is negative 5/8 L. Okay, we're plugging in for t. The 0, the 5/8 is just going to, times 0. So we have 1 minus e to the negative 5/8 L is equal to 0.95. Let's go ahead and subtract, right? Shuffle. So we have negative e to the negative 5/8 t is equal to, right, 0.95 minus 1. We have e is e to the negative 5/8 t, right? This is 95 cents minus $1, so it's going to be negative 0.05. But then I'm going to multiply by that, so we just end up there. Okay. What do you do when you have a variable in the exponent position? We take a natural log, of course. All right. This comes down in front, so we have negative 5/8 t, natural log of e. You remember what that is, of course. That is equal to natural log 0.05. And t is equal to negative 8/5, natural log 0.05. I know that this is less than 1, so it's going to be a negative number times a negative number. T is going to be positive. They said get this to what? How many decimal places? Oh, everybody's 3 decimal places. Very good. So we have 8/5 times natural log of 0.05. Right, and this was t is equal to 4.79793. I know it says negative, but I didn't put this one in, and this one came with it, so I know we're positive. All right, so there we go. That's the lowest, right? The people that are waiting the longest, that last 5% of people, it is about 4.8 seconds. Okay, internet time. That's an eternity. All right. I don't want that. I just want, that was problem number 7, right? Let's look at problem number 12. By the way, with the exception of having you guys fill in the formula, like if I filled in the formula or if they gave it to you like this, I think problem number 7 will be just fine. I would not lose any sleep over it. Actually, I'll be honest with you. I'll tell you this when we get there. 13 is my most absolute favorite my favorite probability question. Okay, I guarantee you, I put this one on the pretest. There's one just like it on the test. I hope that they weren't the same ones, but whatever. But yeah, I always, when I took probability classes, I always liked seeing this one as the first question on my exam because I knew I was going to get one right. Okay. So we have, right, we have f of x is equal to 3 over 343. What do we have here? We have x square root 49 minus x squared. And they said that's a probability distribution. Oh, verify that it's a probability distribution. We have to go from 0x to 7. Okay, so let's see. So here we go. We have the 0 to 7. I'm going to put the 3 over 343 on the outside here. We've got x square root 49 minus x squared. Even though it looks like a triangle, right? I first thought it's like, oh, am I going to have to do a triangle substitution? Like, nah. Let u equals 49 minus x squared, du equals negative 2x. So if I put a negative 2 here and a negative 1/2 out there, we're multiplying by 1, so nothing, no harm, no foul here. Negative 2x dx, right? Yeah, we'll do that, Clark. So this and that is my du. Oops, that one. So we have, I'm going to leave this by itself, negative 1/2, 3 over 343. We have integral, and I'm going to go ahead and just leave it in this way. We'll go back to x space rather than doing everything in u's. So this is going to be u to the 1/2 du. Right? Nice, very tame, very easy calculus problem to deal with. Except that there are parts B and C. Okay. Right. This is going to be u to the 3/2. All right. Oh, I need another one in here. I need a 2/3. Okay. That's why I wanted to leave this alone, because I have a feeling that was going to happen. Okay. So let's go ahead and do the flip. All right. So we have 1/2, 3 over 343 times 2/3. U, oh, not u. Let's go back to x's. Right. X was, this was 49 minus x squared. Oops. The 3/2. You might want to hang on to like this result, you know, maybe. And then what did I do? I flipped them because of the sign. Okay, so we were from, we're at 7 to 0 here. Okay. We're verifying that this is a probability distribution. This should be 1. Okay. So, 7? Yeah, 7. Okay. So let's go. We cancel some stuff, right? This is 1 over 343 because the 2's cancel and the 3's cancel. Right? This 2 and this 2, this 3 and this 3. And now we have to deal with, right? We have to deal with 49 minus 0 to the 3/2 minus 49 minus 7 squared to the 3/2. I'll say 7 squared is 49. 49 minus 49. This is 0. This thing, this is 1 over 343 times 49 to the 3/2. And 49 to the 3/2 is 1, right? Because it's square root of 49, which is 7, and 7 cubed. Oops. 7 raised to the 3rd power. There it is. So I thought that number looks familiar, but check, we're good. It is a probability distribution. Okay. Again, one of those problems that I always love to see on an exam because, you know, these are real straightforward. These are nice. Okay, part B. Oh, good. We only have a part B. Find the probability x is less than 3. Okay, so we want P of x, no, probability, not that, P of x less than 3. Okay, so my integral, we're going to go from 0 to 3, right? We have a 3 of 343 out here, right? What else did we have? Let me set this up. Right, we had an x, square root 49 minus x squared. Okay. So again, we're just going to go through the same little business that we just did before, right? Let u equals 49 minus x squared. du is equal to negative 2x. So negative 2 here, negative 1/2 out here. Okay. That is a du, right? Negative 2x dx is a du. I'm going to keep it, again, in x space. So I'm just going to go u0, u3. And then we have u to the 1/2 power from this. And then, again, I'm just going to leave this out in front here. All right, it's not hurting anybody, so we'll just leave it there. Okay, integrate. And that's going to be u to the 3/2 times 2/3. Right? And we're going from u0 to u3. This is equal to, right, that cancels, so we get negative 1 over 343. Right? And this is 49 minus x squared. And we are going from 0 to 3. Yeah. Go ahead and do that. We have negative 1 over 343. All right. Then we're going to have 49 minus 3 squared raised to the 3/2 power, minus, okay, 49 minus 0 raised to the 3/2 power. That's just doing everything kind of straight. Now you'll see why we swap things around, is because it makes things a little bit easier. Okay, that's what, 49 minus 9 raised to the 3/2 minus 49 raised to the 3/2 power. I don't know. 49 minus 9 is just 40 raised to the 3/2 minus, this was 343, wasn't it? Negative 1 over 343. So that's going to be negative 40 to the 3/2 over 343 plus 1, or 1 minus 40 to the 3/2 over 343. Okay, let's check that out. 40 raised to 3/2 equals, okay, divided by 343, and 1 minus that answer, 0.977, 0.973. All right. Well, there it is. That's not right. This is 40 to the 3/5. That's terrible. 40 caret to the 3/2. Oops, I don't want that either. I want 40 caret parentheses 3/2. As soon as I typed it in, I knew. I was like, that ain't working. That's divided by 343. Sorry about that. Okay. And then 1 minus this value. That's terrible. This is 0.262. One thing about probabilities, the probability itself could never be bigger than 1. Okay, any probability has to be smaller than 1. It's got to be between 0 and 1. Okay, no matter what probability you find, it's got to be between 0 and 1. So if you're calculating a probability and you get a negative number, you screwed up. Go fix that. If you get like 1.2, you screwed up. Go find your error. By the way, I'm not terrible, right? I get mad at you if you give me a probability that's out of bounds. Like if you say it's 1.333, like, okay, no. If you put a little star about this, like, look, I know I made an arithmetic mistake. I can't find it. I'm like, okay, that's now it's an arithmetic mistake. It's a -1 or -1/2 or whatever it is. Not leaving me a little note. that's actually worse, okay? Because you should know probabilities have to be between 0 and 1. If you make arithmetic mistake and just note it, it's like, look, I checked, I couldn't find it, whatever. I'm just going to take off the half a point or whatever I'm taking off for the arithmetic. But to leave this here, I'm going to take off a whole -1, a whole grade. Okay. Again, if you were taking stats from me, it would be more because we go over this more often. Okay. It's kind of like intermediate algebra. You write this down like you're at half. Okay, you're at 50%. If you do it in college algebra, you do it in pre-calc, you say this, like, okay, you're down to +1. I'm not going to try to salvage a grade from that. Same thing with logarithms, by the way. Tell me that that's true. I'm just going to cross it off and give you +1 and move on with my life because that's not true. Okay. All right. Next one, number 13, my favorite problem. Okay. So in this case, right, we have f of x is equal to kx squared times 2 minus x from 0, x to 2. Okay. And 0 otherwise. Okay, that's always good. There we go. All right, for what value of k is f a probability density function? So what we have to do is integrate between 0 and 2 of k x squared times 2 minus x. That's equal to 1. I mean, I really actually do like this problem. This is, there's 3 parts to it, so this shouldn't be all that hard. Okay, so we have k integral 0 to 2, 2x squared minus x cubed, right? It's a nice, very straightforward integral if you know what you're doing. This is a nice problem. So this is k. This is 2x cubed over 3 minus x to the 4th over 4 from 0 to 2. This has to equal 1. If I plug in 0 here, this whole thing, right? If I plug in 0, it's all 0. So let's just plug in 2. So we have k, we have 2 times 2 cubed over 3 minus 2 to the 4th over 4. This has to equal 1. Is 2 cubed times 2, isn't that 2 to the 4th? Right, could we be cute and pull the 2 to the 4th out? And just have a third minus a 4th, right? Which is going to be 1/12, right? If we say 4 over 4, 3 over 3, we get 1/12. And this is 16. So 16/12, what is 16/12? What is that, 4/3? K equals 1. K is equal to 3/4. Okay. That's going to be true for the rest of this problem. Okay, K is going to be 3/4 for the rest of the problem. So parts B and C, K is 3/4. All right. Part B, find the value of K so that, with that value of K, find the probability that X is greater than 3/2. Okay. 3/2 up to 2, right? And then we have 3/4. Right? What's my function? My function was 2x squared minus x cubed. 2x squared minus x cubed. Integrating, we don't know what this is going to be equal to. That's what we're finding out. This is 3/4. This is going to be 2/3. X to the 3 minus x to the 4th over 4, going from 3/2 to 2. And 3/2, like, I don't care if you keep that as a fraction or if you turn it into a decimal place, it doesn't matter to me. Anything with like a 2, 4, 5, 10, 20 kind of thing down here, anything that's going to be a nice easy decimal, you go right ahead and do it. Now it was 2/3, don't do it. Okay, this is going to be 2 to the 3 minus 2 to the 4th over 4 minus 2/3. Notice the 3/4 is on everything. And then we have 3/2 cubed, right? Minus 1/4, 3/2 to the 4th. All right. So same deal. 3/4. This is going to be 16, right? Because the same argument is going to be, and then we have 1/3 minus 1/4 here, because there's still 4 to use. Minus. Oh, this is going to be a little bit harder. Okay. This is a 2/3. That's a 3/2. So one of these is going to cancel. So we're going to have a 3/2 squared. Okay. Because this is almost like a 3 minus 1 here. If I multiply by this, it's going to cancel one of those. Minus. Oof. 1/4. 3/2 raised to the 4th power. That's going to be what? 81 over 16s. Delightful. Okay. 3/4. This was a 12th, right? So that's 16 over 12. Minus, that's 9/4. Plus, right? Minus a minus. So that's going to be 1/4 times 81/16. Right, 2 to the 4th 16. And we just got to sort through all this arithmetic. Okay. So let's see here. We're going to have 16 divided by 12. Okay. Minus 9 over 4. Okay. Plus 81 over, what's 16 times 4? 64, isn't it? Equals. Oh, what happened? Oh, I didn't put a parentheses at the beginning. Jeez. 16 twelfths. Okay, minus 9/4 plus 81/64. All right, so that's 3/4 times that mess. I kind of wonder, right? Math. 67,192. Okay. They don't. I don't care. They said make it decimal. We'll make it a decimal. Okay. So we need this times 0.75. That's a quarter, right? 3/4, and we end up with 0.262. Okay, that's my answer here. All right, next one. Well, not next one, but next part. For that value of k, find the mean. Okay, again, not so bad. I don't know what I just did. There we go. Find the mean. Not so bad here. So we are going to integrate from 0 to 2. We have 3/4 for my k. We've got an x times x squared, 2 minus x. Like a Calc 1 integral. This is nice. So that's going to be 3/4 integral from 0 to 2, because we're integrating the whole thing. X times x squared is x cubed. That's going to be 2x to the 3 minus x to the 4. All right. And we'll just go crank through this, right? This is 3/4. This is 2x to the 4th over 4 minus x to the 5th over 5, going from 0 to 2. If I plug in 0 here, that's going to be all 0. Okay, so I'm just going to worry about the 2 here. Okay, so this is 3/4. This is 2 times 2 to the 4th over 4 minus 2 to the 5th over 5. Hey, isn't 2 times 2 to the 4th, isn't it 2 to the 5th? So 2 to the 5th, I know that that's going to be 32, but we'll pull that out, right? We have 2 to the 5th times 3/4, right? And then we got 1/4 minus 1/5 in here. Right, so that's going to be like a 5 over 5 and a 4 over 4. 5 minus 4 is 1. So that's 1 over 20, 3/4, 2 to the 5th. So that's 2 squared, right? 4 is 2 squared. So we can cancel some of that and get to 3, 2 to the 3, times 3 over 20. Okay. 2 to the 3 is what? 8. 8 times 3 is 24/20. Let's see if we cast out a 2, we will have, well, we can cast out a 4. We have 6/5. Now this is an average, so it's not a probability. If this is over 1, that's fine. All right. So we don't care about the value for this. This could even be negative. We don't care. Right. So how would an average be negative? Like if you're taking temperatures in Antarctica, your average is going to be negative. Okay. For my stats class, we always go over, like, add up all of our net worths. And I just got a mortgage. Mine's a really, really big negative number. So if we add up our net worths, I'm going to have a really big negative number to add in here. So that's assuming that nobody else is in debt. Right? Not a good assumption. So yeah, averages can be negative. That's fine. All right. So that is how we do that one. That's up to 13. I'm going to go ahead and say, I think I'm going to save the rest of this until tomorrow, but I'll post these and we'll see how we go. All right. So try a couple of these. We'll deal with the normal stuff, normal distribution stuff tomorrow, or another recording, the next recording for you. And we'll see how it goes. All right. Take care.